All right, I think we're live here. So I'm going right now into day 9 of teaching myself linear algebra from scratch, just using ChatGPT as my professor, tutor, study buddy, whatever. I'm actually just doing a little bit of review right now. I think there's a lot of stuff, conceptually at least, that has gone a little over my head, or at least that I ought to give more brain power and attention to. So I'm looking right now, I have this saved screenshot on this theoretical proof of how invertibility implies unique solutions. And I'm just writing some notes because I built this little extension all using AI. I didn't code a single line of it, but I built this Chrome extension so I can screenshot things. Then in a new tab, they appear. I can get an AI explanation of them with a button click. I see the AI explanation isn't formatting math properly. Saved AI explanation, format math properly. But I am still reading through this to try to make sense of it. And then it asked me how confident I am about this image. And this is a nice little space repetition tool, I thought. When I say I'm more confident about something, it doesn't show it as frequently in a new tab. But if I am confident, if I am unconfident about it, it'll keep showing it so that I continue to put eyes on it and make sense of it. So I read through this. It kind of makes sense. I'm going to give it like a 4, though, is all. Then I can pick another image to look at. I can look at this one, for instance. A vector in 3D space has 3 degrees of freedom. You need 3 independent vectors to span all of 3D space. So this R3 means. And 2 vectors only gives you a combination in 2 directions. So the span of 2 vectors in this is a line if they are dependent, meaning they overlap. They're just forming a single line. Otherwise, it'll be a plane, a 2-dimensional shape, if they're independent. This image is a little weird. It's a little cut off. I'm going to actually probably delete it. I think maybe it was just a test that I had in there. So I'll delete this. But yeah, I don't want to go too crazy with all this. Oh, let's see this one. Suppose A, B, and C are square matrices such that AB is equal to AC and A is invertible. I want to prove that B equals C. This tests my understanding of the role of the inverse, why we multiply both sides with it. Oh, if A is invertible, I would just multiply both sides by the inverse to solve. I think that's it. Let me get the AI explanation. This will ask ChatGPT to explain what's going on in the image. And this is nice. It actually did format the math properly here. So I'm curious why it formats math properly sometimes and doesn't in other instances. I can save that. Yeah, you multiply both sides by the inverse. I'm going to say it's a 9 for me. Okay. The red dots are for ones I haven't rated yet. Oh, I feel like I did that one. This will get X'd. Right. This is an interesting thing. Subspaces show us how freedom and constraint interact inside a vector space. That's like a 2 for me. I don't really understand the whole subspace thing yet. I'll have AI explain that. So it doesn't do the markdown properly. I'm just making notes to myself as a developer here. Markdown in saved explanation. Bold text, etc. Always jotting down little to-dos. So a subspace is the subset of vectors. Freedom in subspaces refers to the ways vectors can be combined within the subspace without leaving it. For example, in a plane within 3D space, you have 2-dimensional freedom. I know degrees of freedom is one less than the number of variables. So let's see here. That needs to make more sense to me. In a constraint in subspace implies limitations on movement or combination due to the properties or dimensions of the subspace. For example, I like how they say, for example, for all these. For instance, all vectors in a line subspace must lie along that line. A vector space example. If consider three-dimensional space, a subspace would be a plane, like the xy plane, passing through the origin, where you have freedom to move in two directions, but constraint because you can't move in the z direction. That makes sense. So a subspace must include the zero vector. It must be closed under addition, and it must be closed under scalar multiplication. I did some of these problems where I have to prove all those things. The proofs get a little bit tricky. I remember there was some sort of weird math involved, but I'll do more of that. Understanding subspaces involves recognizing how the constraints of dimensionality limit vector operations while maintaining structured freedom typical of vector spaces. Yeah, it's still pretty confusing. I'll move it up to a 3 though. Why not? So without further ado though, I want to jump into today's lesson. I'm going to go up to this chat where I had Deep Research design me a curriculum. I'm now on lesson 3. And I want checkpoint quiz 3. So I highlight this, I hit the quote, give me lesson 3, and then the checkpoint quiz on the first 3 lessons of Unit 2. I'm a real believer in constant assessment. I think that, well, it's not even I think, research shows that taking tests is the best way to learn things. You need to put yourself into this active state of learning and problem solving and thinking. And so I don't just want a final exam and then to be surprised by the difficulty of it. I want frequent quizzes. You'll notice each lesson ends with a mini quiz, and each 3 lessons has a quiz encompassing all 3 lessons as well. So let's look at linear independence. It says this will take an hour. I found these lessons to take closer to 30, 40 minutes. Maybe I'm moving quickly. I don't think I am, though. I think ChatGPT just hasn't fully sequenced this out. Though you will see I talk fast. I like to try to move fast, but let's go ahead and do this. Learning goals, I should be able to define linear independence of a set of vectors. It's pretty straightforward. We did that early on. Linear independence means that they're independent lines. They're separate lines. It's the opposite of linear dependence, where they overlap on the same line or same plane or same whatever it is. Test whether a set of vectors is independent or dependent using the homogeneous equation. Okay, I don't know what that means. Homogeneous equation, I need to figure out what that means. I'll write that down actually in my notes. Oh, I need to go to new day's notes here. So I go here, new notes in freeform, rename, day 9, linear algebra. Nice. All right, so I'm going to write my first note of the day is homogeneous equation. Whoops. Homogeneous equation. All right. Understand how linear independence relates to pivot columns and free variables in a matrix. I think that when you have a free variable, it means there's linear dependence. Is that right? Maybe not. I'm not sure. So I'll have to review that. So linear independence is when, this is the formal way of proving it. If there exists any non-zero solution to this equation, the vectors are linearly independent. So I'm going to screenshot that because I think I need to remember this definition. So I screenshotted that. And then there's this algebraic test for independence. You can test independence by solving the homogeneous system, a matrix times the x vector equals 0, the 0 vector. The only solution is x vector equals 0 vector. Then they're independent. If there's a non-trivial solution, they're dependent. This ties linear independence directly to solving systems. I'll need to see an example with that algebraic test and problem solve, but it sort of makes sense. And then pivot test via matrix row reduction. This says if every column has a pivot, they're linearly independent. If any column is a linear combination of earlier ones, it will lack a pivot or be dependent. So yeah, every column needs a, so yeah, I was right. Free variables are dependence, no free variables is independence. And this is a good thing to note too. I think I basically get it, but I want to still review it. Making a quick note for my thing. Don't show screenshot box area from previous screenshot on same page. I think that'll make sense. I don't like how when I take a new screenshot, it shows the area of the screenshot I just took. All right, are these vectors linearly independent? No. I mean, I can just do that. I can go pick some constants. 1, 2 plus 3, 6 equals 0, 0. And I do this matrix multiplication. C1 times 1 plus 3C2 equals 0. And 2C1 plus 6C2 equals 0. We see the system has infinitely many solutions. So it's dependent. Basically, this matrix is 3 times this one. Are these vectors linearly independent? Yeah, definitely. This one goes in the x direction, this one goes in the y direction, this one goes in the z direction. These form the identity matrix. Each has its own pivot. Yeah. Let me see what it said about pivots. Row reduce. Yeah, you need a row reduce first. Okay. Just wanted to make sure that. So this summary seems good. A homogeneous system has only the trivial solution. That means it's independent. The free variables exist, dependent. Every column gets a pivot, independent. Any column is a combo of others, dependent. I think I'm solid on that. All right, checkpoint. Whoa, we're going right to the checkpoint quiz. All right. I think they skipped some stuff from this lesson. I'm moving way too fast for my own good here, but let's see. Checkpoint quiz 3, lesson 23. By the way, today, if I finish this a little early, which it seems like I will, I'll probably cross-check this cross-reference this unit or this lesson in the last couple lessons on Claude. Just see if they explain things differently or bring up any concepts that ChatGPT did not. I know 4.0 isn't technically the best ChatGPT model to use for math. It's probably 0.3 mini high or 0.1 pro. But I like that it's quick. It does pretty well. It's really nice that it has the context of this document. So I'm continuing to use it. It's sort of that 80-20 rule. I get at least 80% of the results of what I want to know and want to learn. And with, a relatively small amount of the effort. I'd have to use a lot more effort to cross-check all the other things and go through everything more. And the goal right here is to use AI to learn as efficiently as possible. So I'm not going to go too crazy here. Q1, let V be a vector space. Which of the following are subspaces of three-dimensional space? All vectors where x plus y plus z equals 0. I need to explain my reasoning. Okay, so we got the checkpoint quiz. I'll write that down. Checkpoint quiz. One A. All vectors where x plus y plus z equals 0. So in order to be a subspace, what are the three tests again? It has to be, there's scalar multiplication, there's addition, and there's something else. I can tell you right now, this one's tricky. I'm going to screenshot it. Q2 is so easy. I wish they wouldn't keep giving me easy questions. That's the only thing is I want an MIT upper Ivy level understanding of linear algebra, and sometimes they're giving me really easy stuff. So all vectors where x plus y plus z equals 0. When they say all vectors, I'm just a little sketched out. But in order for it to be a subspace of R3, I'm going to have to look up here and see. Or you know what? I'll look at these notes. I just read this, yeah. So they must include the 0 vector. So include 0 vector. Yes, for this first one. Closed under addition. Whoops. Why this iPad pencil is so finicky. Make this brighter too. Closed under addition. If u and v are in the subspace, u plus v is in the subspace. So I need to see how I'd set that up here. This is the Claude cross-check. So oh boy. Oh, this is an old checkpoint, isn't it? No. So are these closed under addition? X1, I think it's yes. I'm just going to write yes for now. But basically x1 plus x2 plus x2 plus y1 plus y2 plus z1 plus z2 all equals 0, yeah. All right. And then I want it to be something with scalar multiplication, closed under scalar multiplication. So C times V is also in the subspace, yeah, because it's equal to 0, yes. So I'm going to say yes. Closed. Good to write this out, even though I said it. I just need to commit this to memory. So in order to be a subspace, it has to be include the 0 vector, be closed under addition, be closed under scalar multiplication. B does not include the 0 vector. Does not, I don't think so, because if you plug in x, y, z equals 0, it's not true. I don't think that's actually the test you do. So I feel like this one is off. Maybe it's still not true, but I feel like it maybe does include the 0 vector. I need to see the test for including the 0 vector. I'll just ask this right now. Say the tests I do to determine and then C is definitely false. All vectors with 0 entries, no. That's way too general. All right, Q2, meanwhile, we're going to that. Q2. Are they linearly independent? No. This unit is pretty easy, or this lesson, I should say, is pretty easy if that's all it's asking me, proving things are linearly independent, because one column multiplies to get the other column. The way they solve it, though, let me see if I can solve it their way. C1 and with C1 and C2. So I'd say C1 V1 vector plus C2 V2 vector equals 0, 0. So I get 1 C1 plus, is it plus? Yeah. 1 C1 plus 2 plus 2 C2 plus 2 C1 plus 4 C2. Dogs, can you please be quiet? Equals 0. I think that's the equation. Does that seem right? Oh, there's two separate things here. Whoops. There are infinitely many solutions to this. I don't know how I would want to solve that further, but I set it up right. I get this one. Q3, are the columns of A linearly independent? Nope, because we have a free variable. Third row doesn't have a pivot. What is the span of the set? What is its dimension? Okay, it's a throwback. The span of the set, it's one-dimensional, and it's a line passing through the origin towards the point 1, comma 1. True or false? Every subspace must contain the zero vector. True. It's just a fact. So, contains the zero vector. Plug the zero vector into the defining condition of the set. Close into vector addition. Pick two arbitrary vectors from the set, add them, check whether the sum satisfies the condition. So I have a u and a v. Close into scalar multiplication. I pick a general vector from the set, v vector, multiply by an arbitrary scalar, check if the, so I pick a c is that arbitrary scalar. Okay, let's see this. So is this what I was looking for? Yeah, okay. W equals the x vector within 3D space such that x plus y plus z equals 0. So first I test the zero vector, 0, 0, 0. It passes, right? Because x plus y plus z equals 0. Yeah. Close under addition. Yeah, it passes all three of these. So if it's closed under addition, I pick two arbitrary vectors. How did I pick these vectors? I guess these are both solutions. And closed under scalar multiplication. If this here's this one solution, c equals 3. I do that multiplication, yeah. All right, give me answers and solutions to each problem in the mini quiz, or the checkpoint quiz, I mean. Took way less than 20 minutes, but I didn't write out solutions. It would have been a little tedious. I think this is faster. By the way, if I have extra time, I need to work on just playing the game of YouTube, TikTok, X, the 3 platforms where I'm posting this. See what I can do to improve reach. I know there's marketing involved in this whole thing, and I want to have more people viewing this over time. I think that there's a lot of power that people can have from realizing you can learn anything with AI, literally anything. A guy who hasn't taken a math class in 15 years can learn linear algebra. I mean, given I do math for a living, I teach math, I am set up to be a good linear algebra student, but I do truly believe that anyone who just sets consistent time each day, is motivated and focused, can learn anything. So excited for what's next with this channel. All right, so this is not a subspace. This is not a subspace. Yeah, it fails the zero vector test. I was right. It's a plane not through the origin, not a subspace. Yep. This one fails the scalar multiplication test. I could have already said that with this one, since 111 is integer entries, that it doesn't work. So the issue is that if I multiply everything here by 1/2 and this by 1/2, it doesn't work. Check if one is a scalar multiple of the other. Yeah, they're linearly independent. So that's the simple solution, I guess. I'll just prefer this. 2 times this one equals that. So they're linearly dependent. I don't know why they put a check. That should be an X. They're not linearly independent. All right, always some weird formatting things with the AI responses. You have to be on your toes. Pivot check. No pivot in column 3. So the columns of A are linearly dependent. Again, why do we have check marks for each of these? Span. Span is a line through the origin, a one-dimensional space. Dimension is 1. Yeah. All right, I got that right. Yeah, all right, those were all correct. Me more problems to solve specifically from this lesson and include some challenge problems. I need more problems. I'm getting to the point now in this unit where I feel like I could combine some of these lessons, honestly. Like I could have probably done 3 lessons in 1 hour. I think they're actually slowing down. I want to take a quick scan back at the overall curriculum and see what they have here. So bases and dimension is next. Again, we've covered this already. Find the basis for things, dimension, rank, null space, and fundamental theorem of linear algebra. That seems good. Oh, is the rank nullity theorem the fundamental theorem of linear algebra? Oh, and I know that already. Linear transformations and kernels / images. Ooh, there's some new words. Identify the kernel and image of a linear transformation. Relate these to something. Determine if a linear map is one-to-one injective or so this is going to be good, or surjective using kernel and image. Understand how changing bases relates the matrix representation of a linear transformation. All right, so lesson 6 of unit 2 here actually seems tough. That's good. Why does it say 9 days though if it's only 6 lessons? I should have looked this over more carefully before. Unit 3 is 1, 2, so orthogonal vectors. So I remember dot products, they teach you that. And I actually don't understand it, but orthogonal I think is basically perpendicular. Complements, yeah, that's perpendicular. Verify the Pythagorean theorem. Orthonormal, Graham-Schmidt process. There's some new stuff here for sure. Orthogonal matrix, orthogonal projection onto subspaces. I'm just doing an overview of the curriculum because I feel like I'm breezing through it a little too easily at this point, that the checkpoint quizzes aren't that hard. Famous last words. Understanding of inner products, identifying orthogonal vectors / sets, performing Graham-Schmidt on a simple set, computing basic projections. What do they mean by projections? So there's some projection formula. I need to understand what a projection even means. Least squares. I know least squares from statistics. Formulate the least squares problem given an inconsistent system with no exact solution. Derive the normal equations and understand that their solution yields the best approximate solution. Interpret the normal equations geometrically. Yeah, I don't know what this is, but apply least squares to fit a similar linear model to data. I think I understand least squares already, but let's see how it connects to linear algebra. That'll be interesting. And then we have eigenvalues, and diagonalization. And advanced concepts, now we're talking. Yeah, this is fewer than 30 days. This is, maybe the tests were supposed to be their own days, and the mini quizzes their own days. I'm not sure, but I'm actually going to finish this in less than 30 days. I've been lying to you guys. This is more like a 3-week course. So there's 12 here, there's 4 here, there are 4 here, that's 20. Wait, did I do that? 12, 4, 4. Yeah, there's 20 days is all. Wow, I'm moving even faster than I thought. Dude, this thing, learning with AI, it's like Bloom's 2 sigma problem in action. Having an actual tutor to teach you gives you 2 standard deviations better results. I'm learning way faster than I would if I paid for some thousands and thousands of dollar course at a local college or community college or whatever. Maybe some are in the hundreds, but it's expensive to go to school to learn stuff. And a pain in the butt. I couldn't just do this in my own house on my own schedule. I have to drive somewhere or go on a Zoom and have someone boring me to death. Now I get to bore myself to death by talking to myself on stream. So the focus will be on 2 key applications: linear regression, principal component analysis. I hear about PCA a lot for dimensionality reduction. Least squares, eigenvalues, and orthogonal vectors are used to handle large data sets and complex models. So I feel like I haven't even gotten into the meat of, I want to see, how do you pronounce this? eigenvalue. This eigenvalue and orthogonal stuff seems like one of the key things. So they do linear algebra and linear regression. That's cool. Principal component analysis and dimensionality reduction. That's cool. Why does it say 3 days and it gives me 2 lessons? Major tests are about 1 hour each. 30 hours of study. Optional unit 5 is 3 days. Yo, I'm finishing this in 3 weeks. Screw it. I'm gonna maybe even combine some days in the future if I'm cruising like I am today. So, practice and challenge problems. So basic scalar multiplication. Stop giving me these easy problems. These are way too easy. No, they're not. Are the columns of A linearly independent? Explain using pivots and the idea of free variables. This is so easy. No, third row doesn't have a pivot, or third column doesn't have a pivot, however you want to look at it. Homogeneous system approach. Determine if the following set is linearly independent. Yeah. You solve this and see if the only solution is the trivial one. Yeah, it's a 3-variable system. I'll do problem 3 because it seems kind of interesting. So if I were to write that out, I would get that x plus z equals 0, y plus 2z equals 0, that's this v2, and x plus y plus z plus 3z equals 0. I think that's how I set it up with this 3-variable system of equations. And I do some substitution probably, like z equals negative x, z. Actually, I want to get everything in terms of z, so I'll go x equals negative z, y equals negative 2z. So then I get negative z plus negative 2z plus 3z equals 0, 0 equals 0. Cool. Yep, it's good. Dimension independence. You have 3 vectors in a 2-dimensional space. Can the set v1, v2, v3 be linearly independent? No, because there's 3 vectors and only 2 dimensions. You need a 3-dimensional space. Dependence from span. Suppose you have 4 vectors in 3-dimensional space. Can they be linearly independent? No. The maximum number of independent vectors in 3-dimensional space is 3. It's the same as the number of dimensions. Challenge 3, construct a dependent set. Construct 3 vectors in R3 that are not all scalar multiples, but are still linearly independent. What? These are way too easy. Those were all pretty easy. Send me answers with solutions. Geez, ChatGPT, you're taking it way too easy on me here. This is not even hard. All right. Scalar multiple check, linearly dependent. Easy. Linearly dependent. Yep. Homogeneous system. Did they do exactly what I did? Yep, this is basically what I set up. I just use x, y, and z instead of c1, c2, c3. Yep, got this equals 0. Oh, what? They said they were dependent. I got that they were linearly independent. I need to ask another model for that because I don't trust that. They're doing it. And the challenge problems, let's see. Maximum vector is 2. Nope. Maximum vector is 3. Yep, very easy. Linearly, I could have just done 1, 0, 0, 0, 1, 0, 0, 0, 1. And not all multiples. Yo, it is linearly dependent. That's crazy. Oh, I guess all real numbers work for that. Negative 3z. I could plug in. For any non-zero value of t, we get a non-trivial solution. So I would need it to be a multiplier of 0 to equal that. Since we found non-trivial solutions to the homogeneous system, they are linearly dependent. One vector can be expressed as a linear combination of the others. All right, so I did get that one wrong. That's actually, I got to check myself before I wreck myself here. So I did make a mistake there. Good to know. Glad I asked for these extra problems, but still not that hard. It's kind of moving slow right now. I'm going to ask it to preview the next lesson. See, I'm 37 minutes into this stream, so definitely less than an hour, but let's go here. Maybe I'm just meant to be a linear algebra guy. But this is starting to make sense. I'm feeling confident. All right. I want to get into this orthogonality and eigenvalues. Those seem like the real useful things. But I guess this is the foundation that I need. I low-key did all of these things already. The rank, null space, fundamental theorem of linear algebra, that's all old stuff. All right. We're doing a second lesson. Do another lesson here. Define a basis as a set that is both linearly independent and spans a vector space. The basis for a column space, a null space, and any subspace of n-dimensional space. Space. Define and interpret the dimension of a vector space. Use basis/dimension to describe lines, planes, n-dimensional space, and abstract subspaces. All right. A basis of vector space is a set of vectors that, I need to just get this in here. Why is this useful? Basis, the minimal building block set for a space. Oh yeah, it's like the Lego block. Every vector in the space is a unique linear combination of the basis vectors. Yep. This is a two-dimensional space. This is a one-dimensional space. This is a two-dimensional space. Dimension is the number of vectors in any basis for this space. And in order to be in a basis, they have to be linearly independent and span the entire space, vector space. So we've got a plane through the origin, x plus y plus z equals 0. The dimensions of w equal 2. Find two independent vectors in that plane. That's a basis. That's a little weird. Explain this further. Is this a problem I'm supposed to solve? I wonder how much better this will be when I can just speak out loud to the AI and have it respond with things. I don't trust the GPT text to speech or speech to text that much. Let's see what they said though. This is the set of all vectors in three-dimensional space whose coordinates satisfy x plus y plus z equals 0. I would think that's a line, not a plane. It's a plane through the origin. Its dimension is 2. You're being asked to find a basis for this subspace. Yes, this is an actual problem. To find a basis for the subspace, I want to describe all the vectors. It's a single linear constraint on 3 variables, so there are 2 free variables. This is a lot. Whoops. Undo. I'm going to get this whole thing in there. So I express this in parametric form. X plus y plus z equals 0. Cool. X equals negative y minus z. So I get negative y minus z, y, z. And I can do this as an addition of the y and z vectors, like so. Negative 1, 1, 0, y. Negative z, 0, z, 1, z. Identify the basis vectors. Okay, so this is making more sense now. Once I parameterize this, that's how I get to 2 variables. These vectors are linearly independent and span the plane. I don't completely understand why isn't just a line. Oh, it's not a line because it's not x, y, z equals 0. It's an equation. Okay, I get it. Degrees of freedom. It's making a little sense. Yo, what? They didn't even give me concept quiz questions. Am I running out of memory here? What's going on? You're cutting me off, ChatGPT. Finding a basis from a matrix. So for the column space, I want to row reduce A. Right? Row reduce A. Identify pivot columns in reduced row echelon form. Take those columns from the original matrix. They form a basis for the column space. So I row reduce A. Find the pivot columns. Take those columns, and they're the basis for the column space. This is worth screenshotting. A little abstract here. I need an example. For the null space, solve A x vector equals 0 vector. Right, the general solution, the vectors that span the solution form a basis. Yeah, guide examples, that's what I need. Basis for the column space. This is good. So I need to get this into, I have a pivot in rows 1 and 2. Take those from the original matrix. I get 1, 0, 0, 2, 1, 0. For columns 1 and 2, I mean. And I get dimension 2 there. It seems pretty basic. Basis for the null space. I row reduce. How did I row reduce? I just made that top one 0. X sub 1 equals, whoa. Let me just make sure I understand that first step they did there. They're kind of skipping around here a lot. So X sub 1. So what I did is I did row 1 equals row 1 minus 2 row 2, right? Yeah. And that made this 1, 0, and then negative 5, 3 minus 8, 3 minus 4 times 2. And so I do that, and this is the new vector. And I can say that X sub 1 I don't understand this. This X vector, how do we get 5, negative 4, and 1? So I need to explain this in more detail. Problem 2, find a basis for the null space of this. So I say that A times some x vector equals 0. Oh boy. All right. And state its dimension. So this subspace, base of this null subspace. So A times x vector equals 0. I'm going to write this out on day 10. Or less than 10. We're doing 2 lessons in one day today at least. So problem 2. Let me look at what they say for this, by the way. The basis for the null space. I understand the row reduction. We got to row echelon form. Cool. I guess the row echelon form just needs the 0 here. It doesn't need the zeros here. That's okay. X sub 1 minus 5x sub 3 equals 0. That's cool. X sub 1 equals 5t. Oh, this is the free variable, this third thing. So that's the t. X sub 3 equals t. That's the key thing here. So the solution set is all scalar multiples of that. The null space is a one-dimensional subspace of the three-dimensional plane aligned through the origin with this vector. Why is the dimension 1? There's one free variable, so there's one dimension in the null space. What is the null space geometrically? They get mapped to the 0 vector when you apply the matrix transformation. What does that mean? Get mapped to the 0 vector or flattened to the origin. That's confusing. Got to keep asking more questions. How much collapse the matrix has. What the heck? The null space is the set of directions that are invisible. They cast no shadow because they're perfectly aligned with the beam. Imagine a spotlight shining on a 3D object. The null space is the directions that give you no shadow. That's kind of crazy. I'm going to screenshot that because that seems interesting. There's definitely some more conceptual connections for you to make here. It's freezing up, I think. And I realized before, I thought ChatGPT made an error, but it didn't. It's a flat, infinite linear subspace through the origin. It's crazy that this is about information. Jeez, this is crazy. The null space is just 0. The 0 vector is trivia. A is injective. It's 1-to-1. And no non-zero vector. This is like a rotation scaling or shear that preserves information. Transformation has full rank. The null space is a line. It collapses 3D space to 2D space. This might be good for what I want to learn about next, which is the secrets of the universe, basically. I'd like to understand string theory. I'd like to understand theories of everything that people explain. if I could go back, I would love to just try to learn try to learn theoretical physics if I went back to college. Even though I don't think I'm actually equipped for that necessarily. There are way smarter people than me who struggle through that. But that stuff's mad interesting regardless. So every vector along the line gets mapped to the zero vector. The null space is a line. If the null space of a four-dimensional space is a plane, then the transformation is flattening part of that 4D space down by 2 dimensions. There are 2 degrees of freedom. The whole degrees of freedom thing is, or directions of freedom, is a little confusing. I'm just gonna write like degrees of freedom flattening. Well, I got 9 minutes left. I want to check this out. Interpret the reduced system. Did I scroll up too far? Yeah. Oh, yo, I want this concept quiz. Oh, what 2 properties must a set of vectors satisfy to be a basis? Linearly independent span of vector space. Every linearly independent set is a basis. No, because it might not span the vector space. True or false? Every spanning set is a basis. No, I want counterexamples. Answer these, including counterexamples, if false. Kind of jumping around. Can a set of 3 vectors in 3-dimensional space be a basis if they are linearly dependent? Nope, because to be a basis, they have to be linearly independent, and there's only 3 vectors, so they won't span the entire vector space. They'll span a 2D space within that 3D space. So let's go down. Nope, nope, nope. Yep, I knew it. So I could have a linearly independent set span only a line, not all of this space. This just goes in one dimension, even though it's linearly independent. Yeah. This is linearly dependent, even though it spans the whole space. All right. Man, it's starting to make sense, but it's not clicking fully yet, this stuff. Like, I feel the limitations of learning it this way without an expert human to talk to. But this is pretty darn good. All right. I got 6 minutes left before my hour is up. So let's go and check this out. Let me get, where were those practice problems? This was their whole, what is the null space geometrically? Okay. Explain this in more detail, yeah. Is this a problem I'm supposed to solve? Yeah. Let's ask for some challenge questions. Does the set S span a subspace of R3? Nope, not linearly independent. Easy. 1, 2, 3, 2, 4, 6. You kidding me? find a basis for this subspace. Those are the hard ones. Find a basis for the subspace and then state the dimension. So I have x1 plus 2x2 plus x4 equals 0, and x3 minus x4 equals 0. So let's see here. I think I can write these as matrices. I think this one would be something like 1, 2, 0, 1. And the other one would be 0, 0, 1, negative 1. So to find a basis for this subspace, oh, each column is a variable. I did this backwards. So it's going to be 1, 2, 0, 1, 0, 0, 1, negative 1. So the question is, what are the free variables? I think that x3, x4 equals t is what I want to do. That's the free variable. There's no pivot there. So x4 equals t, and x3 equals x4. So therefore I have I forget the exact setup of this problem, but let's see. I have x plus 2y plus t equals 0. Hope that's right. I'm going to ask it to answer this for me. This one's a little tricky. Oops. Any set of 5 vectors in R4 is linearly dependent. Justify your answer. I don't know how the proof would look, but it's false. It's 5 vectors, 4 dimensions. One of them, at least 2 of them have to overlap. Counting the dimensions. Suppose a matrix, I don't understand this R5 by 7 has rank 3. What is the dimension of the column space? What is the dimension of the null space? So it's the non-square matrices, I guess. I'd guess it's rows by columns. Yeah. So it has 7 columns. The 7-dimensional column space. Answer this question too. Minimum number of vectors needed to span the column space. The null space is going to be 4 then. Minimum vectors, is it 7 or is it 3? I don't know. Okay, let's look at this. So I have this. I need to find a basis for the subspace. So I say that the x vector is x1, x2, x3, x4. Cool. I always use x, y, z. I probably should switch to their syntax. I want to get some free variables. So I know that x1 is equal to negative 2x sub 2 minus x sub 4. So now I have negative 2x sub 2 minus x sub 4, then the other 3 variables. Then I separate them via parameters. I only then have, so I have x sub 2, it goes negative 2, 1, 0, 0. And I made both of these x sub 4, substituting in. So I got down to 2 variables, negative 1, 0, 1, 1. That makes sense. So the final answer, this is the basis. The dimension, 2 free variables, the dimension is 2. Cool. All right, I'm going to screenshot that still. 5 rows, 7 columns. That's what I thought. Solve the system. It's interesting that these, I was thinking of it as like an n-dimensional space, and that made sense to me. Like we live in a 3-dimensional space. The time is a sort of 4th dimension that's not spatially constructed. But for something to not be like a 3 by 3 dimension space, it's for it to be square is interesting. I wonder what that means in terms of the fabrics of reality. Oh yeah, I'm up to an hour, so I'll wrap this up, then we'll finish the stream. What is the dimension of the null space of A? Dimension of the null space of A. Oh wait, what is the dimension of the column space? It's 3. Yeah. They told me that the rank is 3, so the column space is A. The dimension of the null space is 4. I was right. Oh, to span the column space is just 3. Oh, that wasn't that bad. Okay. Well, construct a basis. Answer problems 3 and 5, just to be complete here. I did 2 lessons today, so I think it's okay if I go a couple minutes over an hour. Usually I go less than an hour with these live streams anyways. But it's the weekend, I got some free time, might as well. Any set of 5 vectors in 4-dimensional space is linear dependent. A basis has 4 vectors, they must be linearly dependent. Yeah, that's basically what I was saying. Just need 2 linearly independent vectors. Just need 3 linearly independent vectors. Just need 1 linearly independent vector. Those are easy. Let's go. Okay. What I do at the end of each thing is I'll go to photo booth. You can see my last one. And take a photo kind of summing up how I feel at the end of each session. So let's do it right now. I think it's a little double clap. That's what I just did. So all right, that's it for today. That'll be the thumbnail for the screenshot for this live stream. I don't think people watch live streams besides checking them out live, but the live streams are an amazing way to stay accountable and stay productive, I've found. It's forces you to be focused. You can't just go and diddle off on YouTube or fall into one of your algorithmic feeds and waste time. You have to do what you set out to do on it. And so I really like this in general as a system of getting things done. Maybe I'll make a video about that as a standalone thing, using live streams as a productivity hack. But thanks for tuning in. It's been fun. It's been real. We're going to finish this course even faster than I anticipated. So that's really exciting to me. Stay tuned and you'll learn more tips to be able to hopefully learn anything with AI. And stay learning. Keep learning.